Problem 43, solve the logarithmic equation. Logarithm of x minus 3 times plus logarithm of x plus 1 equals to logarithm of 7x minus 23. Well, the antidote of logarithm, and by the way, quick notation, log of something means you're taking the logarithm with respect to base 10. That's called common logarithm. You always have a base when you're working with a logarithm. And well, the antidote is going to be exponentiation. Currently, x's are inside logarithms. They're hiding in there, and at the end of the day, you want x equals to a number as your solution. So somehow we have to take them out, and for that, we will be applying exponentiation. So if we have our base 10, whatever is inside the logarithm, base 10, if you raise, that's the power that you need to raise 10 to get that triangle. If you raise 10 to that power, you will get that triangle. So this is how we take it out. But the problem is there are just too many log terms, and this trick only works with one log term. So the first thing I will have to do is I will have to combine the two logarithmic terms on the left-hand side to a single one. And for that, I'm going to use the rule addition outside for logarithm is the same thing as multiplication inside. Addition outside is the same thing as multiplication inside. And then I can put them together, that x minus 3 and x plus 1 to a single logarithm term. And on the right hand side, I have a single logarithm term anyways. 23. And now I can give the antidote. Raise both 10 to both sides separately. So you don't have to write this step if you don't want to write it. I'm fine with it. But I just want to illustrate here what's happening. So instead of triangle, I have whatever is inside those logarithms. So what's the, if you raise 10 to the power, you need to raise 10 to get x minus 3 times x plus 1. Well, you will get x minus 3 times x plus 1. Or alternatively, you can say if two logarithmic terms are equal with respect to the same base, then what's inside should be equal to. And now this is a polynomial equation. So how do we solve this equation? Well, first we have to simplify the expression on the left, and it's going to be a quadratic equation. So we're going to end up moving everybody to the same side. So let's multiply out the left-hand side. X squared plus x minus 3x minus 3. That's how the left-hand side is simplified. I'm okay with the right-hand side. And at x minus 3x, I can simplify it to combine like terms. I can simplify it to negative 2x. And then I have three different kinds of terms. Numbers, x's, and x squares. An equation has only two sides. So I have to move everybody to the same side and use my ideas for polynomials. So how to solve a polynomial equation. So if I subtract 7x and add 23, what do I get? X squared minus 9x plus 20. Now here you can use quadratic formula if you want. Quadratic formula would give me x squared minus 9x plus 20 equals to 0. the coefficients are a equals to 1, b equals to -9, c equals to 20, and the solutions, the zeros of this function on the left, are minus b plus minus square root of b squared minus 4ac divided by 2a, and minus b is minus of -9, and plus minus square root of b squared is 81, minus 4 times 1 times 20, that's going to be square root of 1, divided by, right, 4 times 20 is 80, 81 minus 80 is just 1, and 2a, 2 times 1, just divided by 2. So I will have my two solutions, 9 plus 1 over 2, which is 5, or 9 minus 1 over 2, which is 4. Alternatively, much quicker if you can see it, we can factor this polynomial. Two numbers that multiply to 20 and add up to -9 would be -4 and -5. And zero product principle says either x minus 4 has to be 0 or x minus 5 has to be 0. And from here, we can quickly find either x has to be 4 or x has to be 5. Same numbers that the quadratic formula gives us, but there's just too many computations here. This is faster, but you have to see it, right? But what I'm saying is, even if you don't see it, you have a backup plan. Now, the problem is things with logarithmic equations, you have to be careful. You can't plug in a negative number logarithm of whatever base. That argument has to be positive, or in other words, i.e., domain of logarithm of a function that's 0 to infinity, positive numbers. So that's the reason that these numbers are not solutions, they're only candidates. And one or both of them can be ruled out. So what you have to do is, there is no escape from that, you have to check. So you write your original equation. Let me just copy and paste. And you have to do it twice, right? Two candidates. So if x equals to 4, so I have two candidates, so I'm going to make two checks. So wherever you see x, just plug in 4. So logarithm of 1 plus common logarithm of 1 plus common logarithm of 5, is it the same thing as common logarithm of 7 times 4 is 28. 28 minus 23 is just 5. And the answer is yes, because logarithm of common logarithm of 1, as a matter of fact, for any base, it's going to be 0. So we have a solution for, what about 5? Is 5 a solution? Logarithm of 5 minus 3 plus logarithm of 5 plus 1, is it equal to logarithm of 7 times 5 minus 23? So that's common log of 2 plus 5 minus 3 is 2. Common logarithm of 6, 5 plus 1 is 6. Is it equal to logarithm of 7 times 5 is 35. 35 minus 23 is 12. And addition outside is multiplication inside for logarithm. For that reason, everything checks out. So it turns out both candidates were solutions, and we're done.